Welcome to Mentivia. In this module, we're exploring the fascinating world of isotopes and how variations in neutron count shape atomic mass and chemical behavior. Hi, I'm Mark from Mentivia. Now, we're diving into the fascinating world of isotopes. You've already learned that an element's identity is defined by its atomic number, which tells us the number of protons in the nucleus. But what happens when atoms of the same element have different numbers of neutrons? That's where isotopes come in. These variations affect the atom's mass and can influence its stability and behavior. In this module, we'll explore what isotopes are, how they're represented, and why they're essential to understanding atomic mass. Let's start with the simplest element, hydrogen. The most common form of hydrogen is called protium. It has one proton and, crucially, 0 neutrons in its nucleus. This gives it an atomic number of 1 and a mass number of 1. It's the standard hydrogen we often think of. Next, we have deuterium, often called heavy hydrogen. Like protium, it has one proton maintaining its identity as hydrogen. However, deuterium has 1 neutron in its nucleus. This means its atomic number is still 1, but its mass number increases to 2. This extra neutron makes it slightly heavier. Finally, we encounter tritium, an even heavier isotope of hydrogen. It also has 1 proton, confirming it as hydrogen. But tritium contains 2 neutrons in its nucleus. This gives it an atomic number of 1 and a mass number of 3. Tritium is radioactive and is much rarer than protium or deuterium. These 3 forms are all hydrogen, but their nuclear composition differs. Observe this animation, visually comparing protium, deuterium, and tritium. Notice how the number of protons remains constant at 1 for all 3, which is why they are all hydrogen. The key difference lies in the number of neutrons in their nuclei. This visual clearly demonstrates how isotopes are variations of the same element. So, how do these varying numbers of neutrons affect the mass number? Remember, the mass number is the sum of protons and neutrons. Since neutrons have a significant mass, adding more neutrons directly increases the atom's mass number. The atomic number, which is determined solely by protons, remains unchanged, meaning the element's identity stays the same. This is the fundamental characteristic of isotopes. Let's look at another example from the periodic table. Carbon. Carbon-12, the most common isotope, has 6 protons and 6 neutrons, giving it a mass number of 12. However, carbon-14, a radioactive isotope used in carbon dating, also has 6 protons but has 8 neutrons, resulting in a mass number of 14. Both are carbon because they both have 6 protons, but their mass numbers differ due to the neutron count. In summary, isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. This difference in neutron count directly affects the atom's mass number, making some isotopes heavier than others while their elemental identity remains constant. Understanding isotopes is vital for various scientific applications, from nuclear energy to medical diagnostics and even carbon dating. Thanks for watching. If you found this video insightful, be sure to explore mentivia.com, a free learning platform packed with educational videos, e-learnings, and articles across science, history, and more. Want to keep expanding your knowledge? Subscribe to the channel and stay tuned. There's plenty more coming your way.